So we see that our 12 times 11 times 10 times 9 ordered choices can be grouped into groups of 4 times 3 times 2 times 1, which is 24, but let's leave it in this form for now. And with the same objects in a group appearing in different orders. Okay, so in the groups there are this many ways of representing the same set or the same group of objects. Okay, that means that if we want to look at unordered choices, these ordered choices appear in identical groups of 24. So to get the number of unordered choices, we're going to divide this number by this number, and we get this number. So this is how many such groups there are. Again, each representing a different set of objects. So, and of course we can figure this out. I'll note that the way to figure this out is not to multiply 12 times 11 times 10 times 9, then multiply 4 times 3 times 2 times 1 and divide the results. 4 times 3, for example, is 12. That divides 12. 2 goes into 10 5 times, so we're left with 11 times 5 times 9, which is a much smaller product than this or this. This is over 10,000. This is about 24, and the denominator here will always divide evenly into the numerator. We'll always be able to divide everything in the denominator into something in the numerator. Okay, now let's go on, and let's say we want to choose 5 out of 23 team members to go on the floor. Okay, we've got a team, say a basketball team. We've got 23 people on the team. We're going to choose 5 people to be on the floor. Okay, those 5 will be playing the game. The rest will be waiting to substitute and so forth. So, how many ways are there to do this? Well, by analogy with what we did before, we chose 4 out of 12. This time, well, think about it. What are we doing? And how many ways are there to do it? You should think through this before you see me do what I'm going to do here. Well, okay. By the fundamental counting principle, we have 23 choices for the first, 22 for the second, 21 for the third, 20 for the fourth, 19 for the fifth. So the number of ordered choices is going to be the product of these numbers. That's the number of ordered choices. Now, the 5 people on the floor could have been chosen in any order. Matter of fact, there are 5 times 4 times 3 times 2 times 1 ways in which any given group of people on the floor, any given starting team, say, could have been ordered. So that there aren't this many different teams that could be on the floor, or different groups that could be on the floor representing the team of 23. There are fewer than that. We'd have to divide this number by this number to see how many possible teams there are, because the order in which people are chosen doesn't matter. So we get 23 times 22 times 21 times 20 times 19 divided by 5 times 4 times 3 times 2 times 1. You can't necessarily read all of that because I've done the cancellation. We did that in class. 5 times 4 is 20, so I cross out the 5 times 4 and I cross out the 20. 3 divides 21 7 times. 2 goes into 22 11 times. So this calculation reduces down to 23 times 11 times 7 times 19. Still a fairly big number, 33,000 and some, I think. But that's how we answer the question of how we choose the 5 out of 23 team members to be on the floor. Once more, this many ordered choices, this many ways to order any given choice, any given set of 5, and we divide to get the final result.